In 1977, NASA embarked on one of the most ambitious and far-reaching explorations in the history of spaceflight with the launch of two spacecraft, Voyager 1 and Voyager 2. These twin probes were designed to venture into the outer reaches of the solar system and eventually beyond the familiar boundaries of our stellar neighborhood. Unlike any mission before, the Voyagers combined cutting-edge technology with a profound sense of purpose, both scientific and symbolic. They were built to study the planets in unprecedented detail, but they also carry humanity's hopes, aspirations, and a message for potential extraterrestrial civilizations in the form of the Golden Record. This carefully curated record contains sounds, music, images, and greetings from Earth, serving as a time capsule meant to communicate who we are to the unknown. Its contents, greetings in 55 languages, the sound of mother's heartbeat, a baby crying, waves crashing, and music spanning cultures and centuries, represented the diversity, creativity, and curiosity of our species. The idea that a human-made object could one day encounter life beyond Earth, while simultaneously capturing the imagination of those on Earth, gave the mission a poetic resonance that transcended mere science. From the moment they were launched, the Voyagers proved themselves to be remarkable machines. Voyager 2, in particular, followed a trajectory that allowed it to visit every giant planet of the outer solar system, offering humanity its first close-up encounters with worlds previously only glimpsed as distant points of light. Its journey began with Jupiter, where it captured detailed images of the planet's turbulent storms, swirling cloud bands, and immense atmospheric phenomena. These observations revealed Jupiter to be a far more dynamic and violent world than had been imagined, reshaping scientists' understanding of gas giants. From there, Voyager 2 moved to Saturn, where its instruments revealed a planet encircled not by static bands, but by complex, evolving rings composed of particles that twisted, braided, and moved in intricate patterns. These discoveries challenged previous models of planetary rings and demonstrated that even seemingly simple celestial features could harbor astonishing complexity. The spacecraft's careful observations provided scientists with unprecedented insights into Saturn's atmospheric composition, magnetic field, and moon system, establishing new benchmarks for planetary science. Voyager 2's journey did not stop there. In 1986, it became the first and only spacecraft to visit Uranus, offering humanity a rare glimpse of an ice giant. Uranus proved to be a planet unlike any other in the solar system, with a rotational axis tilted at nearly 98 degrees, effectively rolling on its side as it orbited the Sun. The spacecraft discovered 11 previously unknown moons and 2 additional rings, each presenting new puzzles regarding the planet's formation and evolution. Temperature readings indicated frigid conditions plunging as low as minus 353 degrees Fahrenheit, while the probe also passed through a plasmoid, providing data on the planet's unusual and twisted magnetic field. These revelations highlighted how little was known about ice giants and emphasized the need for further exploration to understand these enigmatic worlds, which represent a class of planet common throughout the galaxy. 3 years later, in 1989, Voyager 2 reached Neptune, completing its grand tour of the outer planets. Neptune's deep blue atmosphere, dynamic storms, and extraordinary wind speeds exceeding 1,200 miles per hour were captured in stunning detail, revealing a planet of raw, chaotic energy. The spacecraft also examined Triton, Neptune's largest moon, uncovering geysers of nitrogen ice erupting into space and a crust suggestive of a possible subsurface ocean. These findings hinted at the potential for extraterrestrial habitability in places once thought to be utterly inhospitable. Neptune's highly tilted and offset magnetic field further challenged prior scientific assumptions, highlighting that even in the outer reaches of the solar system, planetary environments could defy expectations and inspire new models for magnetic dynamics. Each planetary encounter provided insights that rippled through the scientific community, influencing subsequent mission planning advancing astrophysics, and reshaping our understanding of planetary systems both within and beyond our own solar system. The Voyagers were originally designed for missions of roughly 5 years. Yet, both spacecraft have far exceeded these expectations, operating continuously for decades. Their continued functionality is a testament to the ingenuity and foresight of the engineers who built them. Even as their power supplies dwindled to levels lower than a typical household light bulb, the spacecraft continued to send back invaluable data. In 2012, Voyager 1 became the first human-made object to cross the helipause, the boundary marking the edge of the Sun's influence and the beginning of interstellar space. Voyager 2 followed in 2018, offering scientists the first direct measurements of the interstellar medium and revealing the complex nature of the space between stars. Its instruments have detected subtle plasma waves, the faint hum of particles interacting in previously uncharted regions, providing insight into plasma density and other critical characteristics of interstellar space. These findings have expanded our understanding of the universe and demonstrated that even the sparse regions of space are active, dynamic, and filled with phenomena that challenge existing scientific models. Operating billions of kilometers from Earth presents extraordinary challenges. The signals from Voyager 2 now take more than 18 hours to travel across space, requiring extreme precision for communication. Even minor errors can have significant consequences. NASA recently experienced such a situation when a wrong command sent to Voyager 2 led to a temporary loss of contact lasting nearly 10 days. Highlighting the fragility of maintaining a connection with an object so distant that the spacecraft was able to resume operations underscores the skill, persistence, and dedication of the mission team. Each successful communication represents not only a technical triumph, but also a symbolic testament to human perseverance, ingenuity, and our desire to reach beyond the known. Despite these difficulties, Voyager 2 continues to provide groundbreaking insights into the outer solar system, interstellar space, and the fundamental nature of planetary systems. Its discoveries have influenced modern astronomy, inspired subsequent missions, and informed the search for life-sustaining environments on moons, such as Europa and Enceladus. Its legacy has also played a pivotal role in the growing field of exoplanet research, helping scientists refine strategies for finding Earth-like worlds around distant stars and expanding humanity's vision of what might exist in the cosmos. Beyond its scientific achievements, Voyager 2 carries immense cultural and philosophical significance. One of the mission's most iconic moments came not from its encounters with distant worlds, but from a look back at our own planet. In 1990, Voyager 1 turned its camera toward Earth and captured the pale blue, an image showing Earth as a tiny speck just 0.12 pixels across, suspended in a sunbeam. This image became emblematic of the fragility of our planet and the shared responsibility of its inhabitants. The late astronomer Carl Schon eloquently reflected on the image, emphasizing the need for humility, stewardship, and a recognition of our interconnectedness. The photograph has since resonated with millions, shaping public perception of humanity's place in the cosmos and inspiring generations to contemplate both the scale of the universe and the preciousness of life on Earth. As Voyager 2 continues its journey, its instruments are gradually being turned off to conserve power. Yet, it continues to transmit faint but vital signals across billions of kilometers. These final transmissions act as echoes of a mission that has grown increasingly iconic over time. Even as the spacecraft ages, it remains a source of scientific discovery, exploring the interstellar medium, analyzing electromagnetic waves, and measuring particle interactions that were once purely theoretical. The images it captured of the outer planets, from Neptune's deep azure hues to Uranus's ghostly glow, Saturn's delicate rings, and Jupiter's immense storms, remain some of the most breathtaking visuals ever obtained by humanity. Beyond their aesthetic value, these images communicate a story of alien worlds that are at once beautiful and terrifying, inspiring awe and curiosity. They also provide a tangible reminder of the vastness of space and the relative insignificance of our world, encouraging reflection on the scope of human ambition and the enduring quest to understand the universe. Voyager 2's mission exemplifies resilience, persistence, and ingenuity. Its journey across the solar system and into interstellar space represents not merely a scientific endeavor, but a profound symbol of human aspiration. It serves as a reminder that exploration is a fundamental aspect of humanity, that our desire to reach beyond the familiar drives technological innovation, scientific discovery, and cultural reflection. The golden record aboard the spacecraft encapsulates a vision of humanity that reaches across time and space, a species capable of creativity, curiosity, and communication, willing to offer a message of peace to unknown worlds. Each passing year that Voyager 2 continues to function adds to its legendary status, making it the furthest traveled human-made object still returning data to Earth. Its existence in the void between stars is a poetic affirmation of human curiosity, ingenuity, and the relentless drive to explore. Ultimately, the story of Voyager 2 is the story of human endeavor at large. It illustrates what can be achieved when we dare to look beyond immediate needs and constraints, when we imagine what lies beyond and take the first step toward it. Even as its systems slowly power down and its instruments gradually fall silent, Voyager 2 continues to teach us about our universe, ourselves, and the extraordinary potential of human creativity. Its legacy will endure for billions of years, carried by a spacecraft drifting silently through interstellar space. A testament to the courage, curiosity, and unyielding spirit of a species that looked to the heavens and chose to explore. Voyager 2 is more than a machine. It is a symbol of resilience, wonder, and the collective human spirit. Its journey reminds us that exploration is not merely a scientific pursuit, but a fundamental part of what it means to be human. The data it continues to return, the images it captured, and the messages it carries resonate as proof that humanity is capable of extraordinary achievement. Through Voyager 2, we are reminded that even the smallest human creations can leave an indelible mark on the universe, and that the quest to understand the cosmos is also a journey to understand ourselves. Its story, stretching over 4 decades and extending into the vast, uncharted realms of interstellar space, reflects the enduring human desire to reach for the unknown, to discover, and to leave a trace of our existence in the grand cosmic tapestry. This narrative, both scientific and symbolic, demonstrates how exploration intertwines knowledge with imagination. Voyager 2's mission, initially intended to last 5 years, now spans decades, and its discoveries have reshaped our understanding of planetary science, astrophysics, and interstellar phenomena. Its observations of Neptune, Uranus, Saturn, and Jupiter have provided unparalleled insights into planetary atmospheres, magnetic fields, moons, and rings. While its current interstellar work continues to challenge assumptions about space beyond the sun's influence, each measurement of plasma density, each detection of electromagnetic waves contributes to a growing understanding of the environment that exists between stars. Voyager 2 has proven that the boundaries of human exploration are not limited by distance, time, or energy, but by imagination and determination. The mission embodies the triumph of human intellect and curiosity, a continuous reminder that the universe in all its vastness is accessible to those who dare to reach for it.